This lesson will cover how to graph a quadratic equation when it's in standard form. There's several things that we need to cover before we attempt to graph a quadratic. It helps to first start with taking a look at what shape we'll get when we graph. Each type of function has a specific shape when you graph it. In the case of a quadratic equation, you end up with something called a parabola. Now there's several key features of a parabola that we need to talk about. Here's an example of a parabola down here. A couple of the key pieces of information about the parabola that we need to note is number one, the x-intercepts. The x-intercepts are the locations where the graph crosses the x-axis. In our case, you can see that the x-intercepts are labeled right here, and the two locations here and here are where our parabola crosses the x-axis. Now it is important to know that there are either 0, 1, or 2 x-intercepts. Sometimes there's 2. You can imagine if the parabola was up higher, you see that there's a turnaround point on the parabola. If the parabola was up higher, it potentially could never touch the x-axis. Or if this turnaround point, which is labeled the vertex, which we'll talk about in a second, comes down and just touches the x-axis, it's only touching the x-axis in one location. So you either have 0, 1, or 2 x-axes. The next thing to mention really quick is the y-intercept, sometimes also referred to as the initial value. This is the location where the graph crosses the y-axis. Now, for us, in the example parabola we have down here, that location, the y-intercept right here, is down at y equals -3. Another side note on the y-intercept is that you will always, with a parabola, always have one and only one y-intercept. The next piece of information that's important to discuss is what's called the vertex. The vertex is the maximum or minimum value of the function. This can also be thought of as the turnaround point. If we look at our example here, you can see that our vertex is down here right at the minimum value of our parabola. Okay, the minimum value of our parabola. It's also the point at which our graph turns from decreasing in value as we look from left and right to increasing in value as we look left to right. So that's why it can be called the turnaround point as well. But technically it's viewed as either the maximum or minimum value of the function. Okay. Lastly, as a piece of information here, you have the axis of symmetry. This is the vertical line that intersects the vertex and splits the graph into two halves that mirror each other. So right here we have our line of symmetry is this line right here. Highlighted again in blue. We've got this line right here as our axis of symmetry. Again, this line, as you can see, goes through the vertex and splits our graph in half, and each side is a mirror image of the other side. It's also important to label the line of symmetry. The line of symmetry is a vertical line. A vertical line, the equation of a vertical line, looks like x equals, and then whatever value this line crosses the x-axis. In this case, it's at 1. So x equals 1 would be the equation of this line of symmetry. It's going to be important for us to label that when we get to graphing these quadratic equations. Now, something to note real briefly over here, again, we're working with quadratic functions in standard form. The example that we've looked at, just to illustrate the major key components of a quadratic, the parabola opens up, meaning the open side is up and our vertex is at the very bottom. It's a minimum value. You can see over here though we have two separate examples. One that looks very similar to that, in which the minimum, or in which the parabola opens up, and like the example we looked at, our vertex right here, vertex point right there, is a minimum. Now we know that this is going to be a minimum if, as we can see right here, the value of a from our quadratic function, the ax squared plus bx plus c, if the value of a is greater than 0. So if the value of a is greater than 0, our parabola will open up, like this example, and the vertex will be a minimum. However, if the value of a is less than 0, in other words, negative, we have this situation over here at which we can see our vertex is no longer the minimum point. Our vertex is the maximum point on our parabola. And again, the parabola opens down. The parabola opens down. So those are the key features of a parabola, the shape that we get when we graph a quadratic. Now, in order to graph a quadratic, everything starts with the vertex. The vertex is the key piece of information that we need to find in order to graph a quadratic to get the parabola. So right here what we have is we have the vertex formula. It's a formula that if given y equals ax squared plus bx plus c, we can find the coordinates of our vertex. It's important to remember that the vertex is a coordinate on a coordinate plane, meaning it has both an x and y coordinate. The x coordinate is calculated as negative b over 2a. That negative b and the b and the a come from the y equals ax squared plus bx plus c. Okay. Once you have the x coordinate, to find the y coordinate of your vertex, you simply plug your x coordinate into your function and solve for y, and that gives you the y coordinate. So to find the x coordinate, it's negative b over 2a. To find the y coordinate, you plug whatever you got for your x coordinate back into your function and solve for y to get your y coordinate. In a single formula, it looks like this. The coordinate point xy, which is your vertex in this case, is the coordinate point negative b over 2a. There's the x coordinate, and f of negative b over 2a. In other words, you're taking the x coordinate, negative b over 2a, and plugging it into your function f to find your y coordinate. Okay, we'll end up using that formula in the examples that we have next. Just as a real quick step-by-step process, here's the process we're going to follow as we graph the two quadratics that we're going to look at. Number one, you want to calculate the coordinates of the vertex and plot this point on the coordinate plane. The next step is the key step. We're going to end up constructing a t-table around the vertex. This means to select x values for the t-table on both sides of the x coordinate of the vertex. What we're going to find is we'll pick at least 2 points on either side. Number three, we're going to evaluate each x value selected in your t-table for its corresponding y values. What's nice about that is then we will be able to do step 4, which is to plot the coordinates calculated in your t-table on the coordinate plane. From there, it's as simple as step number 5, connecting the points on the coordinate plane that will be in the shape of a parabola. And lastly, as a form of accounting for everything, we're going to label the vertex and 2 additional points, as well as draw and label the axis of symmetry.